Anyone here? Question mark. Here we go. Let's start looking at my live restream dashboard. That one looks good. Go to YouTube, check YouTube. I'm not getting any sound out of my personal machine. So videos live. I appear to be live. Okay, I'm getting sound out of YouTube. We'll check on Twitch to see if people are showing up. Oh, it says I'm live. Okay, exciting. There, Rajat, always the first. Exciting there, Rajat. Oh, I'll pause my, mute that. So, okay, so we have people here. So, Rajat, you're in Toronto like the bunch of us, because you know Daniil, don't you? I think we're all in Toronto. This week is focused on the Toronto Public Library. So this is a very exciting week. Yeah, okay, so that's good. Searching. Week 5 is actually not searching anymore. This one has been updated. So the first step I'll do is update that. This is no longer searching. This is resources and potentially algorithms. Okay, update, save, that's fine. I wonder, has Pebs arrived? Let's see, Pebs is usually a few minutes later, I think. Love Pebs. Love Pebs and Glenn. So, this week today was actually pretty surprisingly hectic in the last little bit, but it was the very last day at my old job. So I am oh, there's Pebs, but having internet issues. That's okay. But it was the very last day at my old job, and I have between now and Friday to myself. The new job starts on Monday, so that's all very exciting. And if we look at this, if this is week 5, so this is 6 weeks since we started the course all around, which means it took me roughly 7 weeks to find a job in Toronto's current market. So I certainly think that we can keep that rolling for the rest of you. Okay, I had a lot of stuff that I've actually tracked down at the library. I wonder if Glenn is around or Josh. And who else? There are some others that stop in, but it says we have 4, so that's good. There he is. Ha ha! How's it going, fella? Here we go. So this week I am going to start by actually I want to talk about, so let's look at the sort of, now here we go. So as we recall, we have I have to leave the chat up so I can see your chitter chatter here. But as we recall, we have the coding interview roadmap, which is intended to be, yay, Glenn! Haha! This is so much fun. Okay, so we have the coding interview roadmap, which and this is week 5. And so the write-up in the document that is here is just the copy from this. Although, based on some of the things that I have found over this week, one of the things that I think we should do is deviate from the actual plan, and talk about the Toronto Public Library resources that are available to us, because I have only just discovered these myself, and they are really, really cool. So we're going to start with, and I will move this off to the side because I don't actually have this written down very well yet. So the lesson plan, discuss library resources. Yes, so discuss library resources. So step 1 for Toronto Public Library is, and my phone just went ding. Is that one of you? No. Oh, there's Gratis. Remember Gratis? Okay. So step 1, Toronto Public Library. Do you all have library cards already, or is this something you're going to have to track down? It's a question we can wait for answers on. I mean, not too long. It's yes, okay. Right, okay, so Rajat, this is going to be huge for you. Glenn probably already knows some of this, probably knew this before I did. And then Pebs, here we go. So under your account, step 1, sign in. I'm going to move that off screen so I can do it without sharing my password or anything. But here we are. So we've got Chesser Alexander, and there is this section called eBooks. There is a section called ELearning. Both of these are incredible resources because, first of all, because we're all locked down in COVID, the ebook content is so. I checked out some. What have I done so far? These were relevant to the things that I've been working on this week. So I looked up like. Mentorship. I went onto a forum and asked for help finding a mentor. None of these are the ones that I found, but ebooks and online content, the audiobooks. So this was it. So 9 powerful practice of really great mentors, how to inspire and motivate anyone. I'm not looking to be the inspiration, but I was asking for help with my 5 and my 10-year plan. And so this was, so like you check this out. They've got unlimited copies and you can listen to it at 2 times speed. And so that's really cool. There's also under ebooks and audiobooks, there are a whole bunch of what I like to call success grifter stuff. And so it's like Tony Robbins and what was the one? Compound Effect. This one was terrible. Compound Effect. It's just like, this is like self-help trash. And okay, so this is one of the ones that I checked out. So you go here, you go borrow. I'm going to borrow this again. How embarrassing. This guy does not deserve to be borrowed twice. He was such like a read now. Oh, this is the actual book itself. But so all of a sudden you've got access to your success grifter content. Where is this, the audiobook or the anyways not chapters, compound effect. It was, I can tell you, so the thing that was terrible about this book, like on one hand it has a whole bunch of interesting tips, right? Like it's The point of the book is if you do something as a habit, so like we're doing this once a week, that has become pretty close to a habit, and that means once a week we're setting our professional development goals. Well, he goes a little further. He says do this every day and do it in smaller chunks, do it a half hour at a time. And over time, what happens if you keep up this repetitive process of doing things? Eventually you reach success. So all of that was really interesting and fine, but it was also really funny because he's the editor of this magazine called Success Magazine, and so he constantly quotes from the articles and the people that he's interviewed. And it's like he'll quote like Dr. Mehmet Oz has this thing, and so it's like Dr. Oz is trying to tell us how to be successful. I'm sorry, but Dr. Oz is a scammer and a grifter, and so like I'm not sure. And another one was Lance Armstrong. So he's like, Lance Armstrong talks about how he won this challenge. Well, yeah, Lance Armstrong in Success Magazine didn't mention the steroids, but anyways, so success grifter content. So you can get all of your business books, you can get mentorship books, you can get sort of, these are things closer to, so you go, these are self-improvement and business are both of that sort of thing. One of the, where's the, available now. So this is what I did to find the books to read. See, this one is actually one that I want to borrow. So here we go. Borrow for 7 days. I want more than 7 days. Anyway, so I can get it for 7 days, and it's not an audiobook, so I'll just return it. That's fine. There's another filter for the audiobooks. What's going on? Anyways, point being, huge, incredible connection of, because I was in ebooks, so you want business ebooks, and then you can say available now. And that's how I found Compound Effect, because it's so terrible that nobody ever checks it out. I learned that one the hard way, but if you listen at 2 times speed, right, and that was the other, so that was the other one I was going to say, is if you go for, and Clean Code is a perfect one to choose, if you go, that was Clean Code, we've got placehold, the O'Reilly Learning was the thing that I was thinking of. So I actually read this one, O'Reilly. So Clean Code, you go to O'Reilly Online. We go, got it. And you can log in. Oh, this is a video series. Hey, maybe I watch that. Maybe I add this. It would be nice if they had bookmarks for that. But the really cool thing about the O'Reilly one, you just log in with your library card, and you just have access to this massive, like, there's expert playlists, recommended for you, learning paths, case studies, recently added. Where's the one for just search? Oh, up here, search for everything. Let's look for React, right? Because we know that we have a huge set of friends who are interested. I'm just going to mute this here. Hopefully this works. Okay. So React, the complete guide, including hooks, router, and Redux. Learning React, 2nd edition. I don't know. I don't know what it was before it was. I think there is another one for what you said. The what was it called? Safari Online or something? Yeah. So I think this is different than Safari Online, but so here you go. Yeah. So there's the React cookbook. There's the Learning React. There's React hooks in action. Um, it's it's essentially the entire O'Reilly book archive, but there's more, and like 10 pages of stuff for React. It's just incredible. Um, so what was the one that there was another one that I actually read? And I want to call attention to it because being Geek. Um, there we go. So yeah, right. And so Glenn, you were you were going to spend 80 or $100 on 8 chapters of a React lesson online tutorial. That's the entire O'Reilly library. It's incredible. It's like, what? And so exciting. Really, like, just the greatest stuff that's out there. It comes out right away. And so, yeah, never mind that one. You've got like, and this is just library. So if you've got a library card, you have online access to all of this stuff. Now, I'm going to go on and look at Being Geek, which is one of the ones I read. I've been listening to Michael Lopp's podcast. Seems to be a nice guy when he's talking to one of his friends, so that's cool. But so here we go. You start reading now, and you go in, and you can just how to win a list of 3, the itch, the nerves. I think it was the itch was interesting. Was an interesting one. So each of the chapters in his book, in this particular book, is about a different phase of your technology career. He's a very senior manager. He's been at Slack. He's been at Netflix. I don't know where. Let's try and Google his Michael Lopp LinkedIn. I'm going to try and check his LinkedIn. He appears to currently be at Apple. This is Michael Lopp. His Rands and Repose is his blog. We will talk about that in a bit too. But so he's an engineering leader at full time at Slack. He did 4 years at Slack. Surprisingly, no Netflix. I thought that he had Netflix in there, but so he went from Symantec to Borderland to he was at Netscape in the 90s. Anyway, so this guy has been a isn't Sunnyvale where the Hellmouth opened up in Buffy the Vampire Slayer season 7? I don't know, maybe. Palantir, 4 years. So head of interest at Pinterest or a head of engineering at Pinterest. The guy is heavily experienced in high end anyways, so this guy's book is broken into, maybe I look at this one. So it's broken into 3 main sections. The one is section 1 of how do you start looking for the job. The next one is how do you manage your life in the job. And so it's the different archetypes of people in the job. And then the last this is as opposed to this stuff that I call success grifter content, this stuff seemed to be pretty useful overall in terms of working a bit like a, he's a high level engineering leader, and this is how to operate like a high end engineering leader. The trickle list was, let's see if I'll pull that one up. It's a shorter read. There is, and then this is, so it's like how to find your job, how to work with your management and culture of your job, how to, or things to do every single day, and then how to decide to move to the next job. So 50% of the book is about leaving your job. But it's like, get the job, work with your manager, work in your job, look for your next job. And so the trickle list was one that stood out for me, as was the itch. So we can kind of go through a couple of samples. My expiration date is historically, he typically sticks around places for 3 years. He says, he doesn't ever really have a plan, but like as soon as he picks up the phone from a recruiter, he knows, okay, it's time to start looking, because I'm starting to think about maybe there are things that are more interesting externally. And if you start looking early before you get to being pissed off, right? And he talks about this. This chapter is not about being pissed off, but I should have done highlights. Look, I could have done this. I could do add a highlight. Look at that. Because I've read the book. I read the book over the weekend, but I did not make highlights for all of you, which I could have. But anyways, he says if you're pissed off, that's not what this is about. This is about making a strategic move at the right time. And he talks about the factors that contribute to when do you know that it's time for you to start looking? And he's sort of like, are you less engaged? Do you find yourself with wanderlust? How much time are you thinking? Right. So if you are not, because technology is this kind of thing where we're solving crazy puzzles all the time, and we really enjoy working on these puzzles, and you get so excited by the work that you're doing that you're thinking about it outside of work. And so if suddenly you find yourself, or slowly over time, you find yourself, I'm really not thinking about how worried I am about solving this big problem, maybe that's the sign that it's a good time to move on. Now, I personally have the opinion that there are times in your life, like for example, if you were getting married in the next 5 weeks, it would be kind of nice to not have to worry about these crazy next level puzzles. But like at the same time, it's like, keep these things in mind. And so I am in the middle right now of highly recommending being Geek, even though, so, and then he talks about, here it is. So the rolodex, or is the list of people who you will have a phone call with after, he says, they don't leave you. You don't leave them. You leave the current employment, but you keep your friends because you can stay in touch. He has this wonderful piece. I don't know which chapter it's in, but he talks about how you find what he calls your people. He says, they're my people. And he says, I think it's in the chapters where he's talking about going to conferences and because the scope of being a programmer is so strange related to the rest of the world, right? We have this very arcane knowledge set, and we do these things that other people think are weird or magic. And he has this wonderful thing that our people are the other people who get really fired up and excited about this. And that's how we and we could be separated from our people for months, or a year, 6 months, a year, and you sit down with them, and it's like you hadn't been apart at all, because you just tuck back into talking about the cool technology stuff, and you don't have that everywhere in your life. And that's, in this context, that's a very encouraging thing to think about in terms of going to a new job, because he's saying don't be afraid of it. The 20 to 30% raise that typically happens when you go from one job to another is quite nice. But anyway, so that was a really good chapter that I identified with, having just gone through that whole process. But each of these chapters is really it carries with it a different lesson, right? So the Exodus was about what happens when a place has a whole bunch of departures at the same time, and should you think about leaving around that? Anyway, Deliberate Career was very good. It was a lot like my article on professional development that I wrote over the weekend as well, which maybe I don't know if you've all seen that, so I might bring that up for a second as well. I think it was based on what we had talked about in a previous session anyways. So in fact, I see there are at least two new people, so I might bring that up anyways. So the book, very good. The trickle list was super interesting to me, so I'm going to talk about that one as well. We've got, so here's an actual photo of his trickle list, which is probably enough to figure out what he's doing. No, let's go up to here. So his trickle list is a list of non-mandatory daily goals, and this is the list. So I'll add a highlight to that. So he says, today, every day at work, I would like to have a random chat with somebody in the hallway. Now, we can't do that under COVID, but you can do a Slack chat or something. Now, Lopp is a writer, so he will, he says, I've got to write something every day. He's concerned about his health, so he says, I want to take my vitamin every day, learn something about the business, and read something. So they're non-mandatory, but they're super achievable. They're tiny, tiny goals, like have a random chat with somebody. So what he does is he just writes this thing, and he gives himself I imagine the zeros are the days where he doesn't do it. So he said, so if he has his random chat, I guess that's probably the hallway chats. He gives himself an X. And just like this Success Grifter book that I was talking about, where he says doing tiny things every single day adds up over time. Sorry, we're gonna... Florida. Why the hell is Florida phoning me? Also, I thought this was on mute. Sorry. Tap that. Where's my do not disturb button? Do not disturb. Okay. It's probably a spam call. Anyways, so just like the Success Grifter stuff, this is tiny things every single day. They add up over time. So he's got his 47 random hallway conversations where over time he learns things that are new and interesting, and so that's good. Highly recommend this book. Highly recommend Michael Lopp's stuff. And the next thing, I'm going to open my Slack, is because this guy has an online persona called Rand. His Rands is the persona name. How do you open this? Rands in repose. So we go there. Rands in repose. So his books, he has multiple books. They are highly recommended by others. I've only read this one so far. The books are generally based on his blog, so you could read his blog, but he also has a Slack channel, or a whole Slack instance where there are 16,000. So 16,000 technology managers and want to be managers, or so send an email with your name, occupation, and the briefest explanations of why you want to join the Slack and how you heard about us. Please include a link to your LinkedIn, Twitter, Medium, anything that demonstrates you're a real human. None of the above. Michael Lopp calls himself Rands in the context of his website. So he grew up in the days where we all had handles. So, but this is a leadership Slack. Some of us work for a VP who is absolutely on this. I learned accidentally. But if I open the Slack, this is so you go to your intros. So this is the Rands in repose. I don't want to share the other people who are in it, so I'm actually not going to drag it onto screen out of respect for the others who are in it. But the people who are in it are CTOs, engineering managers, senior staff and principal engineers, people who are currently managers, engineering managers, people who are aspirational managers. You can read all about this. So I should make sure that this is in the lesson plan for today. Networking strategies. This is one of the ones. Discuss proactive networking. That's a learning objective. It doesn't get a link. Check out some. Okay, so architecture documentation. This one dot space, is a consider trying to join the Rands leadership Slack. Okay. So they have sections in there on mentorship and coaching. They have sections in there on help and advice. They have sections on, they have 16,000 people, and they have discussions every day around leadership, career management. They have a help and advice section where people can just ask questions about, I'm struggling for this, or how do I get my next job in whatever, so it seems to be a really great resource to network and level up in terms. So all of that through this library, and through reading this book and some of his others, have been so valuable, that in fact these are not. No, I want to go down to the homework section. choose an audiobook or book. Right, because we want to talk about LinkedIn. Choose, just going to change that to book. From TPL. There we go. That's good enough. It's one of the things. One of the things that everybody should do this week is look through the books and pick one to read through it. So where is the search? What are some of the other ones that I thought were really interesting? So we had clean code, but there was also a ton of stuff on like architecture, security software architecture, serverless architecture. So if Gratis ever watched this, or if anybody saw Arthur around, I know Arthur is like so excited about serverless architecture. So that would be one that integrating serverless architecture, orchestrating data workflows using a fully serverless architecture. And that's just a video. Anyways, it's legitimately mind-blowing to me how much good content there is in here. So this is a playlist. So this is, if you want to, so this is really cool. So it's just, there's so much in here, so much in here. Now, are there any thoughts on that, or are we all, have I sufficiently gotten people excited about the learning that can happen from O'Reilly Online through your library card? Serverless Fire Swamp. I feel like I want to watch that one too. Yeah. Serverless architecture. Just all of this stuff. There's so much to. It's a little overwhelming. There's so much to read, but like so much good stuff. Anyways, so now with the fact that we have that handled, we should also take a moment to look at the next section was e-learning. So their e-learning section has a section for, so O'Reilly is, you're right, it is formerly Safari, and I guess it got bought by O'Reilly or something. I don't know. But lynda.com has now become LinkedIn Learning. And again, you can just log in on another screen. Oh, why do they not? Oh, devastating. Okay. Here we go. Continue. So, part 2 of interesting things that I've found this week is we've got LinkedIn Learning, which is formerly lynda.com. And now, one of the problems with doing your LinkedIn Learning through the Toronto Public Library right now is if you finish a course. I did this personal branding one this morning for fun.
Influence marketing and Google Ads. They're all great tactics to help.
We don't have to watch the whole thing. You don't have to watch that for me, but I'm trying to see where it says that you can download your You download your, maybe I go My Learning, I go Learning History, Completed More, and I can do Download Certificate. So you download your LinkedIn Learning Certificate, and it's a PDF. So I've got my certificate of completion there. There it says. It doesn't even say I did it. Where's my name? Well, that's bullshit, pardon my language. That's a bit disappointing. But the point being, you still learn this stuff, even though their certificate is crap. And it turns out, and I spoke to LinkedIn help and support about this. There's actually a setting. There's there's actually Is it spelt wrong as well? Congratulations. No, it's spelt wrong, but it just doesn't have my name. It's like, oh right. Okay, so this is actually the problem with. Okay, so this is part of what I was complaining about, because if you complete a course in LinkedIn Learning through the paid version, and so maybe some of you have an employer who is paid for this in the way that has this checkbox enabled. If you do it through a non-Toronto Public Library version, which is if you pay for it, which is almost $500 a year, so probably not, but corporations will pay for it, and you can log in as yourself into the corporate LinkedIn account, and then you can post the learnings that you do directly to your LinkedIn profile. And so as you do something like TypeScript, then over time your LinkedIn profile will begin to fill up with short certifications. So 1 hour, 2 hour, 3 hour, 4, 8 hours. So you got nearly 10 hours of learning TypeScript. And then again, we say React. So you can do React.js, and they have 43 courses on 3 learning paths. So 6 hours and 58 minutes of guided instruction on how to. Here, let's just look at the learning paths. Here is, I happen to have a friend who is really interested in learning a little bit more about the MERN stack right now. Actually, that's my new job, is going to be in the MERN stack as well. But like 24 hours of dedicated instruction, if you do an hour a day, is kind of perfect, right? Build a virtual reality application with React, which I did not know you could do, but these are save. So these are really good and a great way to step up, because, as you can imagine, start the learning path. The problem is, as you finish the certificates, they don't have your name on them. So, and you can't actually post them directly to your LinkedIn account. And so I actually tweeted at the library. They have not responded yet, but I CC'd John Torrey and my local counselor to try and get some answers on why we can't post these directly to our LinkedIn accounts, because it seems to me that especially for younger people in marginalized communities who don't have a corporate gig where they pay for a full license to this, or who don't have $500 a year to spend on this, are likely, it sort of creates two tiers of education and training. If you can do the work but you can't get the credit on your resume. So I think it would be nice if the Toronto Public Library went ahead and enabled that, but I don't know who to talk to at the Toronto Public Library to make that happen. I still think doing 50% of it is doing the actual courses, and so I still think it's worth doing. If you are at a company that has LinkedIn Learning already, I would say go through that account for now. But I also think that the library will likely, hopefully after considering the option, maybe they will make it so that you can get your name on the thing that you did. So frustrating. But still, it's a lot of really great free learning content. So that's worth paying attention to. This was one that I thought was interesting. So on to the next subject. We've got, and to review, library is amazing. We have LinkedIn Learning, we have OReilly Learning, we have actual books, and we have audiobooks. The tech content of the audiobooks isn't that great, but the OReilly stuff is incredible. This one was really interesting, probably mostly for me, but if you were planning on so these are architecture guides from Azure that have they're from Microsoft, they're from Azure, that have exceptionally good broader appeal. So architecting cloud native .NET apps on Azure, the fundamental principles of this book, for example, will also have, is this the one that I was reading? Introduction to Cloud Native Applications. So this might not be the one I was reading. There was one I was reading that was really interesting. Microservices. Sorry. Docker. Doesn't matter that much. Microservices. Let me try this one. Sorry. I should have done a better job of getting... but the lesson, it's not that important. The lessons learned out of these Microsoft architecture guides will be generalizable to broader application designs, because architecture is really about not making strong commitments, or anything that you can do in Azure, you can probably do in AWS with a slightly differently named service. And so if you are, most of you are not looking to go into the sort of next architecture level, but if you were, this would be a good place to start. Although the library is probably the best place to start. So I did want to call those out because I thought they were good. Go through the architecture documentation. Changed my mind. That sucks. So what what have the rest of you been doing in terms of your growth and development, or have you been doing additional algorithm questions at all, or have any of these things? Josh you have an excuse. You've been planning a wedding, so that one is okay. Front end masters from Rajat, that's good. Let's bring this up and see what it is. Advance your skills. Browse our courses. Rust programming. Are these free? How much are they? Intermediate React. Okay, so $2,000. Oh, that's a team. But still, $390. So that's cheaper than LinkedIn Learning for a year, but it's not that far off. Or actually, it's probably almost. Oh, okay. So, yeah, and I think LinkedIn Learning will have the same one. The thing about LinkedIn, these, I don't. Oh, actually, Jem Young, I follow him on Twitter, so these are probably really good. I probably want to watch that. I wonder if I can get access to it somehow. Anyways, front end masters and and the learning paths. And so you in theory, by the end of the learning path, you are. Do you get a certificate or anything that you can post to your LinkedIn? Because 50% of doing the course is knowing the stuff on the other side of it, but there's also the fact that you want to get the credit for it, so that when recruiters, for example, are doing a search for people who have this particular skill, your profile is going to come up. Because, like, let's go back to, here we go, 2.7 million people have watched their way through this one. And so, but let's look at this learning TypeScript one.
To better describe your code by living.
And will it say, and so this one has been bookmarked by 5,000 people, and I don't know how to see. So 15,000. So if a recruiter is doing a search, or a hiring manager is doing a search for people who know TypeScript, and then they also want to geolocate the search. So out of 15,000 people in the world, 16,000 people in the world, I'm one of the people who started it, and there'll be even, maybe it's 5,000 people finished it. I don't know. So one of 5,000 people have this certification in TypeScript, and then, maybe there's 20 in Toronto or something. And so getting that certification means you start coming up in the search results. And that's where step one of finding your new programming job comes into play. Is you've got the discoverability. In fact, this is stuff from lesson 4 that we skipped because our special guest didn't show up. But so the structure of the recruitment process as a whole is the employer realizes that they have a need in the business. So the manager says, I've got all of this extra work that needs to be done. They talk to the recruiter, or they do their own search. Anyway, they talk to the recruiter, and the recruiter goes into their candidate management system and starts typing in keywords based on what the employer has said. So if the employer says, I need React and TypeScript, well, your name is going to come up higher on the list if you have a whole bunch of formal training tags within your LinkedIn profile, which is, so then they reach out to you, right? And then you do the pre-screen, the tech. So the pre-screen is they make sure that you're a living, breathing human. The tech screen is you might hop on a phone call and do, they might say, what's a variable? Or so, they ask you a couple of easy questions just to get a sense of your technological prowess. Then you might do a paired programming interview where you solve an actual problem like the ones that we looked at last week. And then you have your big day marathon interview with... Anyway, so this was... getting those certifications on your LinkedIn fills that spot in step 2. Right? Step 2, they're more validated than something that you just put on your resume yourself, because it's from an actual course, right? And so, but it's not quite as intense as getting an AWS certification or whatever. So getting those courses onto your LinkedIn, critical stuff. So here we go. And then, right, so I put that in, consider trying to join the Rands leadership Slack. So that's the first half, and I think I got through everything that I needed to do there. And so the other half is back to talking about algorithms for another week and watching just somebody else try and go through a few algorithms to get the sense of how we talk about these things. Here we go. And so let's start. This one's hopefully... So this one's an easy one. So we're not actually going to try and solve this one today, but we're going to read the problem and then look at the solution and try and dig into the way that they're talking about things. And I am not sure if this is one of the ones that said... Oh, here we go. So given an array of numbers and a value of value, remove all instances of that value in place and return the new length. And so this is an array right? So you have an array, so many characters long, and you just want to go along and remove. It says, do not allocate extra space for a second array, and you must modify the input in place with O of 1 extra memory, which means a constant amount of extra memory. I'm not sure. The order of the elements can be changed. It doesn't matter what you leave beyond the new length. Right. So, confused why the returned value is an integer, but your answer is an array? Note that the input array is passed in by reference, which means a modification to the input array will be known to the caller as well. Okay, so the problem here, so by passing in the array, I hope all understand what by reference means in this, but that's, if you don't, you want to know what that is before you go to test. But effectively, I can explain it. When we say by reference, when we say we pass in by reference, The array is sitting in a block of memory, and instead of copying all of that information across, we just point to it. And so we, inside and outside of the function, we're pointing to the same object. JavaScript works like this on objects and arrays pretty much, so this should be pretty standard to you. Okay, so if they want to if you had the input of 3, 2, 2, 3, and the value of 3, you would want the length, because the new length of the array is 2, and you want the array to have no number 3s in it. Right? And by not, and anyways, so if you want to remove the 2, so bam, length equals 5. Okay, so we're not going to solve that here, but we want to talk about what the solution. We're just going to jump to the solution, right? So says it's an easy problem that can get confusing because of the in place, and because in many languages, many languages, you can't actually modify an array like that to remove elements altogether. So these are the hints. They want to say try 2 pointers. Did you use the fact that the order of elements can be changed? So, and what happens when the elements to remove are rare? I don't know. Anyways, so the nice thing, I'm going to scan through this, right? So this one gives you multiple approaches. This is what I was hoping for, or hoping to discuss in terms of the algorithm solutions. So the question is asking us to remove all elements of the given value in place, but we want to handle it with O of 1 extra space, and so that's constant space, right? If we have an I and a J, where I is the slow runner and J is the fast runner. So, and here's the block of code that does this. Int I equals 0. So when the nums J equals to the given value, skip the element by incrementing J. As long as nums does not equal value, we copy nums. Here, I'll highlight this so you can also read it yourself, right? So increment both indexes and repeat the process until J reaches the end of the array and the new length is I. Remove duplicates from a sorted array. So the time complexity, so int I equals 0. So let's see, so the nums array, for I we start at the very beginning of the array, and for J we start at 0 but we go through the length. So if the number so in the first spot, if the number at 0, 0 is not equal to our value, we copy a piece of the array into the place where we are, and we increment I. So right, so it's like as you go through the array, if you find the number, if the number is not the value that you're removing, you copy it into that spot. And you increment I by 1. And so you are overwriting the values that appear. Okay, so hopefully you get this. I should have done, you know what I should have done is had some pictures ready where I drew out what was actually happening from this. And so that's a lesson for next year that I am going to write down right now, because this would have been far better. So go through architecture docket, check algorithm solutions, lesson plan, notes for next time. Actually draw out a solution to make this clear. I like this. I like the solution. I'm sorry, I could have done this better. Remove, there we go, solution copy. But if I had drawn this out, it would be very clear. So you should all just imagine that I did a really good job there. Oops. Next, 2 pointers when elements to remove are rare. Now consider cases where the array contains few elements to remove. For example, right, okay, so the problem I guess when this one is, if it's the operation you have to do, you're always copying, you effectively copy the entire array if you're moving things along. So if the value is exceptionally rare, you are doing unnecessary copy operations because of the way that that's structured. Right? So in both of those cases, your operations are much higher than they necessarily need to be. When we encounter nums at I equals to the value, we can swap the current element out with the last element and dispose the last one. So that essentially reduces the array's size by 1. Note that the last element was swapped, could be the value that you want, but don't worry, the next iteration will still check this element. So this is the one that I thought of as probably the one that I would have gone for first. But so so I starts as 0, so I is the beginning of the array. N is the last element of the array. And it's the number that you return. And so you move your cursor forward, right? So so if the number at 0 is equal to the value that you're removing, you reduce, you take the value from the end of the array and you put it into the spot that you're deleting, and then you reduce the size of the end of your array. And so you still go through the entire array once, but you're not doing as many memory swaps. Now, the time complexity and the space complexity are still the same, which is funny because, you've got O of n here, and you've got O of n here. So in theory, they scale the same and it should be fine. But this one is clearly more efficient. And I guess big O just doesn't handle everything. So that's interesting. So I'm not going to do another one of those in that style. It was worth trying, but I feel awkward for not having done actual diagrams of this. So I'm going to skip to commit those changes because I needed that note, but let's just watch some. this one. Let's watch this one.
What if you could control the web?
How is this sound?
What if telekinesis was real? An interface for the same exact CSS problem.
Okay, so this is
Hello, hey, what's up, guys? Nick White here. I do tech and coding stuff on Twitch and YouTube. Check the description for all my information. It's got
sounds
everything.
good. Thanks.
Today we're going to be doing House Robber, very popular problem because everyone loves dynamic programming, even though it doesn't come up that much. People spend way more time doing dynamic programming category problems than any other category, which makes no sense because they don't show up that much in interviews, but it's okay because I'm going to do them here for you guys, so you don't have to worry. House Robber is one of the easier dynamic programming problems. I'm going to just go over the easy ones first. You got Fibonacci, you got climbing stairs, and then you got House Robber. Those are the easiest ones on LeetCode. And yeah, let's just do it. So you're a professional robber. You're pro at robbing and stealing, and you're just, ready to steal. You're planning on robbing houses along a street. So you want to just go down the street, rob all the houses. Each house has a certain amount of money you would expect. And the constraint that stops you from robbing these houses, not your morals, but the adjacent houses have security systems that are connected. So you have 10 houses on a street, but you can only rob maybe like 5 of them or 4 of them because 2 houses next to each other are connected by security, and they'll call the police if you rob 2 houses next to each other. So you have to be careful which houses you rob because you want to get the most money you can. So what we're going to be looking for is, given a list of non-negative integers representing the amount of money you can rob at each house, determine the max amount of money you can rob without alerting the police. So we have a bunch of houses, we can't rob 2 houses next to each other, and we want the max amount of money without alerting the police. 2 houses next to each other, we'll alert the police. Here's the array of input. We're doing a method called rob. And we'll get an array of numbers, integers, non-negative integers, and this is the amount of money we can steal from each house. So one house is going to have $1. It's very worth it for us. We might have jail time, but who cares? We're going to get $1. So $1.
Nice.
We have 1, 2, 3, and 1, right? We can let's zoom in here. We cannot rob the first 2 houses, house 2 and 3, or 3 and 4, because if we rob 2 houses next to each other, police are coming. We don't want to run. We don't want to break out of jail and all that stuff. So we're just gonna have to. We can rob 1 and 3 because they're not next to each other, or we can rob 2 and 1, right? So what's more, 1 plus 3 or 2 plus 1? Come on, I'll let you pause the video and figure this out. It's 1 plus 3. That adds up to 4. 2 plus 1 is 3. So we want to rob the first and the third house because we get $4 instead of $3 in the other option. Let's look at the other example, right? We can rob 2, 9, and 1, or we can rob 7 and 3. So 2 plus 9 plus 1 is 12 versus 7 plus 3 is 10. So we rob $12 over $10, right? And we make it out alive, right? So intuitively, what are we doing? Well, we're skipping indices, right? We're looking at the first index, skipping the second, going to the third. Or we're looking at the second, skipping the third, going to the fourth. Or we're looking at the first, third, fifth, second, fourth, right? So it looks like you're skipping, you're going on even and odd indices. So you're thinking intuitively, like I thought of this at first, like, okay, we'll have the sum for the even indexes, sum for the odd indexes, and we'll take the max of those sums, and whichever is more, then we'll do that path, right? But that doesn't work. It's not that simple. You think it's that simple? Well, think again, buddy. Think again, Buster. Because, oops, we're going to zoom out here. Just trying to do Control-C. Look at this example here, right? So let's add a 1 and a 100, right? So what's the max here that you can get from this problem? You can't rob adjacent houses. So you can't go these, or these, or these. Oh, no. But what we're going to do, so if we did even numbers, we can go 1, 3, 1. 1 plus 3 plus 1 is 5. That's not that much. Or we can go 2 plus 1 plus 100. That's 103. Now, that's a lot, right? So that's what we choose. But that's not right. The answer isn't 103. Because you can do 1 plus 3, skip 2 houses. You don't have to rob houses if you don't want to. And then just go right for the 100. See that? So you can go 1 plus 3 is 4, plus 100, that's 104, compared to 2 plus 1 plus 100 is 103. Right? So you don't have to rob a house. You can skip over houses if you want to. Okay. So we have to use dynamic programming, like I said in the beginning, to solve this problem. And, well, the first way you think about dynamic programming problems, I'm going to make a video just talking about categories and how to solve them probably, but the process is usually you think about it recursively, you draw out some kind of tree of what's going on. So if you drew a tree, you can use memoization or arrays to store repetitive calculations. So if we did brute force, what is brute force? Think about it. We could chart out every possible path, every combination of houses we could rob, and how much money we would make from those different combinations. We just, every possible, so in this case, we do this, there's 2 combinations of houses we could rob.
The laptop lifestyle, needing just this to do your job and not having a boss. It's very...
Or actually, there's a bunch. We could just rob this house. We could just rob this house. We could just rob this house. We could rob this house and this house. And we do every combination, and we pick the maximum of those. That's pretty slow. That's super inefficient. And you'll see repetitive calculations, and that's when you want to use memoization. If there's repetitive calculations, when you plot out your tree, you get a pen and paper, you plot out your tree, you find repetitive calculations, you use memoization, you store calculations, and then you can use them from the array. You can access them. So that's what we're going to use. We're going to use dynamic programming to keep an array of maximum values as we loop through the array of houses, right? So as we loop through each house, we're going to say, we're going to keep an array of maximum money we've made from the houses so far. So we'll start out with $0. We'll look at the first house. Okay, the first house, we're going to see, okay, the maximum we can make so far, just from looking at the first house, is $1. Then we look at the second house, what's the maximum we can make so far now without robbing adjacent houses? It's going to be 2, because we can't, if we choose between 1 and 2, it's going to be 2, right? And we just keep that array and we go through the whole thing. So that's the whole thing we use dynamic programming for. So let's just write it out and then we'll go through some examples. So first of all, if nums.length is equal to 0, meaning there's no houses to rob, we're just going to return 0, right? We can't, the max is going to be 0, there's no houses to rob, so we're going to make no money. Next, I'm going to give you the template for dynamic programming problems here. You have an array, and it's usually called DP or memo for memoization. Not memorization, memoization. So I'm going to call it DP, and this is going to be an integer array for the maximum values, and it's going to be set, it's always set to the size of the input, plus 1 usually. It's not, this is just a template. If you look at all the solutions for dynamic programming problems, this is always pretty much the template. You set initial state or initial values.
So what's interesting about what he's saying in this one is, and it's sort of that piano analogy that we talked about in a previous week, where the programs or the algorithms all seem to fall into these same categories, and you start to recognize them as archetypes over time, and that's part of the reason that you want to do these. Like the success grifter content says, just do a half hour a day. Just do one a day, and over time, over the next few years, you will do them like they're Sudoku, right? It's like Sudoku, but for getting paid more at work. So, like, better Sudoku.
So the first value is going to be the maximum when we first start out. The maximum value we can rob from 0 houses is 0. We start with 0, we're robbing no house, we get 0. Now we're going to set, it's usually you set the first 2 elements of your dynamic programming array. If we look at the first house maximum value we can rob from 1 house is always just going to be equal to the value of the house, right? And we know it's non-negative integers, so it's not going to be less than 0, so we don't have to do a check, you know? Now we start our loop. We already checked the max from robbing the first house, so we can start our loop at 1. This is usually still part of the dynamic programming template, and while we loop through all of the input, sorry, I'm on a new keyboard here. You just loop through from I equals 1, and then this is part of the template too. This is all just standard template stuff. You return your DP array nums.length. And this is the last element of your DP array, because the last element of this array is always going to be the maximum amount we can rob. So we're doing the maximum amount we rob without alerting the police. The last element of this array at every point in the array is going to be the max that we can rob of the houses. Does this make sense to you guys? I hope it does, because I feel like I'm explaining it decently. So all we have to do now is really simple. We just have to calculate the max at the next step, right? So at each house we look at, we're calculating a new max. So the new max is going to be equal to dp of I plus 1. The newest max is going to be equal to math.max of, we can check the previous max. So the previous max is just the latest element of the dynamic program, right? So when we look, we set our max when we see no houses is 0. When we see 1 house, the max is the current house's money. So no house is 0. First house, 1. Next house is 2. So we do the math.max between 1 or...
There is more fear, uncertainty, distrust, doubt, and division than ever before.
Nope.
dp of I minus 1, which is 0, right? Plus the new house. So the old max plus the new house. And that's because the old max will be a house away. It won't be an adjacent house. And the new house won't be an adjacent house with the old max. So we can add it onto the old max and see if it's greater than the new max. If it's not, we just leave it. Alright, that's pretty much it. That's the whole problem. Boom. That's it's pretty straightforward, actually. So there you go. DP array just keeps the maxes. I'm going to go through an example right now, so let's go through the examples. We'll do the first example all the way through. So first of all, we'll start with 1 and 2. We'll start with the first 2 elements of the array. Our DP array, we initialize to nums.length plus 1. Nums.length is 2 in this case. So DP array is going to be size 3. So it's going to have comma, comma. There's going to be 3 values here. Alright? 3 values we have to fill in. First value is going to be 0. Boom, because that's how much money we have when we rob no houses. DP of 1 is going to be nums of 0, which is 1. Boom. DP, now we loop through from, we started I equals 1, I is 0, I is 1, I is 2. So when I is 2, we set DP of I plus 1, which is 1 plus 1, which is 2, 0, 1, 2. So the next element, the newest max, is going to be equal to the max of DP of I, which is 1, the current max, or the previous max, which is 0, plus the current element, which is 2. Boom, it's going to be 2. So if we stopped here, we'd return the last element of the array, it would be 2. That would be the max on this input right here, which is a fact. Okay, let's look at now we have 3 and 1, right? So the next element we want to look at is 3. We're looking at 3. Boom, next element of the DP array is going to be equal to math.max of 2 or 1, the old max, plus 3. 1 plus 3 is 4, which is greater than 2, so we put 4. Okay, now we're looking at 1. dpy plus 1, the next spot in the array is going to be equal to the max 4. So we're looking at 4 versus dpy minus 1, which is 2 plus 1. So 4 versus 3, it's still 4. So you do 4. The maximum is 4. You return 4. Boom. Thank you for watching. That is how to do dynamic programming problems. This is basically how it looks every time. The only thing that's different is this line right here. In most dynamic programming problems, sometimes if you're dealing with 2D arrays, it'll look a little bit different, but this is like standard, kind of like this part standard, starting at I equals 1 standard, returning the last element is usually kind of standard. So thank you for watching. I know that you can use variables to improve on this, but they don't expect that in an interview. Usually, sorry for burping, but that's the end of the video. Please like and subscribe so I can promote the channel. I'm making a doc. I've been working on it for a while.
There we go.
The React documentation is lying to you. That got your attention.
It did get my attention. I'm still not going to watch your ad. So, like, I should have actually had... So what was that? That was Leak Code 198. Leak Code 198. Now, the downside of this is I really should subscribe to LeetCode so I can share these things, because this is actually locked. But if you look at, for example, here, and you are mostly JavaScript. JavaScript solution 198. So let's look at a few of these. JavaScript one-liner. I don't like the one-liners mostly because I feel like they skip the... So this is apparently the faster than 90% and not super great on memory. But anyway, I mean but math.max of this and this. Anyways, so the thing about, if you have not subscribed to LeetCode, so you can't look at the solution themselves, you can actually go into the forum and look at the solutions that are posted in there, and this, just like he said in the video, they're all kind of the same. It's kind of solved in a similar way, and apparently, if you get to the point where, some of these are ugly though. Oh, this one's really ugly. I don't like this one at all. I can't believe that one actually works. That's not recursion, and my recursion is too slow. Yeah, that's... Oh, are you trying to solve it right now? I didn't think that... this is... I actually kind of like this one if you're using JavaScript reduce. Huh. But this is what is, if you go through and you do these and you do enough of these, just like he says, if he recognizes, this is just the same question again with a slightly different solution, so they're all that's part of the value of doing these. Just pick one a day, pick 2 a day, or do a half hour a day and do them like Sudoku. So let's go back and see The Find the Judge, I watched that. I didn't quite like that one as much, so we're going to try this guy.
With MailChimp's customer journey smarts, you can track when a customer buys something.
So what's this? Leak code.
Hey, what's up, guys? Nick White here. I do tech and coding stuff on Twitch and YouTube. Check the description for all my information. You can, I post a bunch of stuff on my Patreon. If you want to, I'm having a tough time talking. Support me or whatever, and reach out to me on Discord, Patreon, whatever. Try and get back to everyone. This is a very famous problem that I was looking through. I was like, I can't believe I didn't do a video for this. I've gotten this in a bunch of interviews, and I think it's like the best 2D array problem, like medium level, give you a great understanding about 2D arrays. But yeah, let's do it. So you're given an n by n 2D matrix representing an image, meaning we have a 2D array we're given. If you don't, I would assume you guys know what a matrix is, or 2D array, like this. Where n by n meaning like rows and columns, we have the same number of rows and columns. So like in this example, we have 3 rows, you can see here, and then we also have 3 columns, right? N by n. So that represents an image. Rotate the image 90 degrees clockwise. Okay, what does that mean? So I would just say, imagine picking this 2D array up and just rotating it clockwise. And like you would see, like if you just pick it up and rotate it, like you would see the top is gonna, you can see it's gonna come and it's gonna become the right side, and then the right side's gonna go to the bottom. All the sides like shift over one, so you know what I mean? Like the right goes. You guys know what a clockwise rotation is, so 1, 2, 3 becomes the last column. Whatever I was just saying also. 7, 8, 9 is going to become the left, 3, 6, 9 is going to become the bottom. But, so we just want to do that. We just want to rotate it. And there's a strategy to do this. I would say check out the video transpose matrix. I think I did that one before because that's a technique we'll use here. One more thing to note is before we do this, you have to rotate an image in place, which means you have to modify the inputs 2D array directly. Do not allocate another array for the rotation. So we're not using extra space. This is a void method, meaning we don't have external data structures, we're not returning anything. We want constant space solution. And if we want to go through the example really quick, right? Like I said, you're taking the first row becomes the last column, basically. And the last row becomes the first column. 1, 2, 3, last column. 7, 8, 9, first column. And in this example, 5, 1, 9, 11 becomes last column, then in order of that, right, column-wise. But it is difficult, right? It's difficult to take, just looking at it, if you just wanted to loop through and take 1, 2, 3, and then what do you do? If you're looping, regularly you loop like this, right? You go 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you wanted to do 1, what do you swap with the last element, but then the 3 is over there, you want the 3 on the bottom, so it is kind of tricky when you first think of it, but if you do it in 2 steps, it's a lot easier, because what we'll actually do is, I think I can paste this, there we go, I wrote this out, and then I found this in the discussion. I think it's really useful to explain this. So this is in the discussion. I think it's some guy named Lucky Idiot or something like that. So shout out to you, Lucky Idiot. But the idea is to transpose the matrix. Check out another video where I explain this. But basically what you're doing is you're looping through, and you can see what's happening is you're swapping. The diagonals stay the same, but you're doing a symmetrical swap on the diagonals pretty much. So you see 2 and 4 here become 4 and 2. 3 and 7 get swapped to 7 and 3. You could see 6 and 8 get swapped to 8 and 6, and that's it. And then once you have that, basically what this is doing is it's taking the rows and turning them into columns. It's not making the first row the last column, which is what we want, but it's making the first row the first column, second row second column, third row third column, and that's going to help us because once we're in this form, it is pretty easy to go to this form. Because what we just want to do at this point is just, we'll loop through each row, 1, 4, 7, and we'll have a pointer at the beginning of the row and the pointer at the end of the row, column-wise, and we'll just go towards the middle, like a two-pointer approach, and just swap values. So you swap the 1 and the 7, you get the 7 and the 1, the 2 and the 8, the 8 and the 2, the 9 and the 3, 3 and the 9. So what you just do it in 2 steps, and then what happens is you do get this thing where you got the first row, you get that rotation. It's just about making the rows into columns and then kind of reversing the column order using a two-pointer approach. So that's the idea here. Let's write it out, and then I'll trace through it for you guys really quick. I wrote this trace out right before just so you understand. So I'm going to grab the length of the array because it's the number of rows and columns, so we're going to be looping. Always a lot of loops in 2D array problems, so I would suggest making a variable for the length. So I less than rows, I plus plus. This is just a standard loop through the 2D array. J is going to be set to I, so pay attention to that. J is going to be set to I, and I'll explain that in a second. So this loops through the rows, this loops through the columns, and then we do our little switch. This is transpose matrix. So we're going to do a temp variable to the current element, just a regular, when we're regularly looping. Then we're going to say, okay, matrix of current element is equal to the swapped value. So the row and column value will be equal to the column value as the row, and then the row as the column. And I will explain that right now. And then because we lose reference to I of j, because we set it, we change it here, we have that temp variable to save the reference so that we can do this. And this is how to transpose the matrix. And let's look through the trace. What this is doing is, in our example, for like, if we have, 1, 2,
there's some value to the way that he's solving this in terms of he has this trace up. That's really close to, again, like in these code interviews and things. This is the kind of explanation that you would be expected to provide as it's going on, because if you were or potentially expected to, I mean, I certainly got my latest job in a much easier and more friendly way than the level of pressure that goes on, but it really does go back to. And part of the reason I think that I want to make sure that I take the time for future sessions to do a bit more work around drawing out these boxes and everything is if you are in an interview, it is nice to explain to the interviewer what's going on with the memory and being able to step through and walk through this content in a way that explains all of the values at any given point in the
3, 4, 5,
process.
6, 7, 8, 9.
So-
Then at 0, 0, the element is 1, right? We're just going to do a swap. It's going to do nothing because 0, 0, 0, 0, right? It's all the same. Like the row and column values are all the same. But we're going to loop 0, 1, right? Now we're at 0, 1. That's the next current element. So what we're going to do is we're going to swap the position at 0, 1, meaning this 2, with the position at 1, 0. So it swaps on that little diagonal right there. The column acts as a row for reference, and then we swap these values to do that little switch. And, that swaps the 2 and the 4, makes it 4 and 2, and then it gets to, 0, 2, then you're at 3, and you do, okay, 0, 2 equals 2, 0, so the 3 is equal to the 7. This only works for a perfect square, by the way, that's why it works here. And, there you go, you got that perfect swap, and then you go on to the next row, which you start at that 5, then you go on, you go to the 6, you swap the 6 and the 8, and then you're at the 9. So you set the J to I because you want to move along with the rows as you do this. And that's pretty much it. I think it's pretty self-explanatory at that point. Then we just want to do that two-pointer approach I was talking about. The rows we're still going to loop through casually, right? Like I was showing you here. The rows for the two-pointer approach, when we're swapping the left and right values as we go inwards, we still want to just go row by row. So we're going to go for a row and then go have the column values, one at the beginning, one at the end, go inwards, swap, and then go to the next row. So the rows were still going to go up to n, but the columns were only going halfway because it's two-pointer. If you're familiar with two-pointer approaches, we just have a pointer at the end and beginning, and we meet in the middle. So we have j is less than n divided by 2, which is the middle. And then we just set a temp to the current element, matrix I of j. We say matrix I of j, current element, is equal to the ending column, so the beginning column values, the first pointer is equal to the second pointer, which is starting from the end. So we do the length minus 1 to get the valid index, minus j, the position. And this will be the same distance from the beginning to the same distance from the end, these pointers, as they go towards the middle. And then, then you just want to set that to the temp like we did just above, and there you go. That's the two-pointer approach to flip the columns, get them reversed, 100% solution. It's linear in regards to the number of elements in the 2D array. So some people say O of n for n elements in the 2D array, or O of m times n for number of rows times columns. But these are not nested, they're separate, and we're not using data structures, so I call this a linear solution, constant time, linear in regards to number of elements in the array. But I love this problem. I think, understanding this is, really important. Maybe watch the transpose matrix if you're having trouble, and also you want to know, it incorporates a lot of methods, like two-pointer, swaps, and, transposition, so. That's it for this video. I thank you guys for watching. I appreciate every single one of
Click
you.
like on his stuff.
And I am gonna go and do some more problems right now. So I'll see you in the next video. Alright.
There we go. This guy, we should take a second to highlight Nick White, who has I love this. You can actually watch him get older in his channel, but he has what's the number of videos that this guy has? Does it actually say how many uploads? I wish it would say the actual number of uploads, but if you look, he just goes on and on and on. And so he has done so much work in explaining this stuff for people. Look at this guy. He just keeps going. He's incredible. He's a machine. So this guy's really good. He is really worth paying attention to. Now, let's look at, we have a solution. So we can actually, now that we've gone through that in this context, we can go through so there are pictures for this one. So we can iterate over each group of 4 cells and rotate them. So is this one with, rotate, so approach number 1 is rotate the groups of 4 cells. Okay, so visualization of the algorithm in action. Oh, look, we can actually play. So let's watch the video. How long is this? So you've got see you next week. Yeah, we're finishing up soon anyways. I just think this video needs music, but this is the level. This is so cool. This is the level of stuff that this is far better than the stuff that I should have done. This is next level. so there we go. And the nice part is that this one, or these solutions in LeetCode, they actually tell you the complexity analysis. Is O of M makes that linear. Each cell is getting read once and written once. That's good. Space complexity. Okay. Now here's another one. The most elegant solution for rotating the matrix is to firstly reverse the matrix around the main diagonal and then transpose. And here it is. So we're going to watch this one, which is a 40-second video. Right, so that one even just felt faster. I guess they solved them in two different ways, but even though this approach does twice as many reads and writes as approach 1, most people would consider it a better approach because the code is simpler and it is built with standard matrix operations that can be found in any matrix library. So, well, that's an interesting question, is since it scales linearly as well, if you're not too confident with matrices in linear algebra, get some more practice by coding the method that transposes the matrix on the other diagonal. Okay, that's a good interview. Terrified of being asked this question in an interview? Many people are. It can be intimidating to do the fiddly logic. Unfortunately, if you do a lot of interviewing, the probability of seeing this one at least once is high, and some people have claimed to have seen it multiple times. This is one of the few questions where I recommend practicing until you can do it on your... So, anyways, again, this is... this is one that's really good to know. I've done one similar to I've done this one, I think, before on Hacker Rank as well. But these are, so it's a common question. It happens a lot, and it's super good to know, and it's good to practice. And so let's see. Oh, this is week 4. We want week 5. Oh, this seems. Does it seem like an unfair? I don't think that's so. It's, you know what? There's two ways to think of it, because you might be right in some ways that it's unfair, but also if you've seen it before and you've practiced the hell out of it, then it's also trivial, right? Like it does seem like it's super hard. It would be super hard to be solving this one for the first time in an interview. But I think now there's a difference between the reality of, yeah, right? So part of the higher end, I call them higher end, but it's part of like the big, the the FAANG companies or the big 5 tech companies is they want to hire people who have done the grind. And so if you've done the grind and gone through these, you've probably seen something or a variation of this quite a bit. And so going through and doing it is probably I don't know. It's tough to say. It's like it would be shitty to be solving this for the first time in the interview, but they're hoping to get people who haven't solved this stuff for the first time, right? So yeah, and you know, and I think that's part of the problem of the hiring. Yeah, and so if the company's asking these questions, pay like crazy, which they mostly do, then just do the practice. There's so much discussion going on right now about how the tech interview process is kind of shitty. It kind of sucks. And so people are talking about redesigning it, talking about doing it another way. And that's really good. And I really hope they do. And from the context of standing on principle, you say, oh, well, I don't have to do it. But the reality is, if this is worth 200 or doubling your salary, does 30 hours or 40 hours of work, so 1 week of work in terms of hours to double your salary, is the return on investment there is like super high. Understand testing algorithms, but this specific question, you need to know how to transpose and reverse, and that has nothing to do with coding. I think what's interesting is I actually saw, the first time I saw one like this, it wasn't this one exactly, but it was to spiral a 2D array, so spiral the values of a 2D array somehow. So it was a lot like this. And it took me some time, but I solved it on my own, and then I went to the question. I went to the forum or whatever to find other people's solutions. But it's just, you get kind of torn. I get kind of torn because it's like, it's the game. It's the game. It's the game. It's the grind. It's shitty, but there is no other solution right now that I know of. Anyways, so week 4. We're week 5. Week 5, and but good to know, yeah. Well, I think, honestly, yeah, I don't know that watching that get solved once is enough to memorize it, but I think a lot of these things have to be practiced like piano so that you can just whip them out. So we're moving on to try and do one a day, try and do them like Sudoku. Go through the amazing book list and check the courses on LinkedIn and choose one. So those are our goals for the week, and we'll take a second to look at next week because we are moving on to timed practice. So it is more about algorithms next week. And I still want to try and find a way to do this stuff better. I think if I'm doing this course in future, maybe trim down these sessions or find a way to organize it better. So This is coding interview roadmap. So 6, 7, and 8 are more complex problems, stepping up. I don't know that we're actually doing these yet, so there's a big question around what do we do to step up on the algorithms, because this system design stuff is really interesting. So anyways, that's the week, and we hope to see you again next week, and I can't wait to hear what books you've each picked. So thank you. No problem, Rajat. See you later, Pebs. Josh, if you're still around. Yay, Josh is still here. And we'll talk to you later.